Hello everyone, how are you? Fine, okay. See, I will show you a picture to you. This is a rope pulling game. Have you seen such games in autumn days? Yes. So in rope pulling game, there are two groups. Both are pushing the rope in opposite directions. Only one group is the winner. What's the reason for the success of one group and the failure of the other group? Does force has any effect on it? Let us see in detail. Okay, this is a book. Now, yes. So I am trying to push this book, see, by applying force in this direction. I will show once more. I am applying force from this direction. Does the book moves? Yes, the book moves. This is case 1. I am pushing the same book by applying force from opposite direction. I am applying the same equal forces from opposite direction. See, does the book moves? No, this is case 2. Okay, so have you heard about the unit of force? Yes, Newton. Newton is the unit of force. So I am applying 50 Newton from here. Consider that I am applying 50 Newton from this direction and applying 50 Newton from this direction. What happens? They get cancelled out. Okay, see. So what is the unit of force? Unit of force is Newton. 50 Newton is applied from this direction and 50 Newton is applied from this direction. So net force is 50 minus 50 equals 0. 0 Newton. So in that case the book doesn't move. So in which situation the book cannot be moved? In case 2, when equal forces are applied from opposite direction. Okay, in which case or in which situation the book moves? In first case, when I apply or pushing the book in one direction. Okay, does force has any effect on it? Or what is the reason for the movement of the book? Force. Okay. So from this what we conclude that force is needed to move object. And when equal forces are applied in opposite direction, no motion occurs. Okay, I shall give you 5 pictures. Okay, based on these pictures, you have to complete the table. So in the first picture, we can see that 2 persons are pushing a table. So here F1 equal to 50 Newton, F2 equal to 50 Newton. Okay, then in the second picture we can see that 2 persons are pushing the table in opposite direction, but they are applying equal forces. So F1 equal to 50 Newton, F2 equal to minus 50 Newton. Okay, in the third picture we can see that the persons are applying forces but they are unequal forces. Okay. Here F1 equal to 80 Newton, F2 equal to minus 40 Newton. In the fourth picture, we can see that it is a game. Now, here the both persons are applying equal forces 120 Newton, but they are in opposite direction. In the fifth picture, we can see the rope pulling game. Okay, here one group applying 400 Newton forces and the other group applying 300 Newton forces. So let us see how can we complete the table. So the first case is 2 persons are pushing a table from one direction. Here F1 equal to 50 Newton, F2 equal to, yes, they are from same direction. So for F2 equal to 50 Newton. Then what about the net force? Yes, the net force equal to F1 plus F2, that is 100 Newton. 50 plus 50 Newton, that is 100 Newton. Then what about the second picture? Here the persons are applying equal force but in opposite direction. So in this case, F1 equal to 50 Newton, F2 equal to minus 50 Newton, and the net force equal to F1 plus F2, that is F1, here F2 is equal to minus 50 Newton, and we get the answer 0 Newton in the second case. Then what about the third case? Here both persons are pushing the table in opposite direction but with an unequal force. So here F1 equal to 80 Newton, and what about F2? Yes, F2 equal to 40 Newton but in opposite direction, therefore there is a negative charge, and F2 equal to 40 Newton. Then the net force is equal to 80 minus 40 Newton, and what will be the answer then? So the net force is equal to F1 80 minus 40 Newton, and we get 40 Newton as the net force. And what about the fourth case? Yes, here the F1, it's a game and both are applying equal forces in opposite direction, and here the F1 equal to 120 Newton and F2 equal to 120 Newton, but F2 is applying in opposite direction, hence there is a negative charge, and this negative charge gets cancelled and we get the answer as 0 Newton. 120 minus 120, 0 Newton. Okay, then what about the fifth case? Yes, here F1 equal to 400 Newton, F2 equal to 300 Newton, but it is in opposite direction. So minus 300 Newton. Then net force equal to F1 plus F2 is equal to 400 minus 300 is equal to 100 Newton. So the next is 100 Newton. So you have to complete the table. By completing the table, we can conclude that if the total force or the resultant force is 0, then the applied forces are balanced forces. If the total force or the resultant force is not 0, then the applied forces are unbalanced force. I will show two pictures. Okay. See, this is case 1. In case 1, we can see that two pulleys are fixed to both sides of a wooden block. Here this is a wooden block and two pulleys are attached to it. And to these two pulleys, equal weights, that is 200 gram of weights are suspended. Both have equal weights, 200 gram of weight. This is case 1. Okay. Then I will show another picture. This is case 2. In this, here the wooden block is attached to two pulleys, but the two pulleys contain different weights. One of the pulley contain 100 gram and the other pulley contain 200 gram of weight. So see the difference. Here the wooden block moves towards this pulley. Now, so this is case 1 and this is case 2. Then when equal weights are suspended to the pulleys, the force applied to the wooden block is balanced or unbalanced. Which is the force? Yes, the forces are balanced because equal weights are suspended. Then, is there any movement into the wooden block? No, the wooden block doesn't move because here the forces are balanced forces and equal weights are suspended. Then, is there any movement in any case? Yes, case 2 shows movement of the wooden block. Now, yes, here the wooden block is moved towards the weight which contain 200 gram of weight. 200 gram has more weight than 100 gram. So here the wooden block moves towards the 200 gram of weight. So this is an unbalanced force. No. What we conclude from this experiment? Yes, when an unbalanced force is applied to a body, there occurs a change in its state of rest or the direction of motion. I will show two pictures. See, in the first picture, we can see that a man is pushing the vehicle by sitting inside the vehicle. And in the second case, we can see that, in the second picture we can see that a man is pushing the vehicle from the ground. No, here the man is applying the force from the ground towards the vehicle. So these are the two pictures. So does the vehicle moves in both cases? No. So in which case the vehicle move? Yes, case 2. That is when the man pushes the vehicle from the ground. Here the man is applying the force externally. So external force is required to move the vehicle. And what about the first case? In the first case, the man is pushing the vehicle by sitting inside the vehicle. Here the man is giving an internal force, and internal force cannot move an object. I will give an application level question. When a bus is break down, people push the vehicle from outside. Why? Yes, when a bus is break down, people push the vehicle from outside because here the people applies force externally. So in order to move the bus, an unbalanced external force is required. That is why the people push the vehicle from outside. I shall give a written assignment for you. What are the balanced forces that act on a book at rest on a table? Note it down on your science diary. I shall also give an activity assignment for you. Make a list of unbalanced forces using in our day-to-day life. Okay, thank you.